Let's get started. The calculator. Okay. Everybody's got the book? We're all ready to go? Okay. So here we go again. The province usually does not give us any conversion rates. So to be safe, I would say you should all have these ones on there just in case on your study sheet. But can you make them really, really small? Like, don't use up too much of your study sheet for these ones. A couple things that come to mind right here that I can give you like a shortcut if you want to write this down. 1 inch has 2.54 centimeters, but it also has 25.40 millimeters. If you wanna relate inches and millimeters, there you have it. Okay. The other one that I can think of right now is 1 gallon has 3.79 liters, and since there's 1,000 milliliters in every liter, you can just add this one as well. Okay, so we can do some basic conversions here. This is a review from last year, so you can convert rates or units. What's the difference? So the first two, A and B, is just converting from one unit to the next. C is converting a rate, which is, right, 2 different units, this many liters per minute, to a different set of units, right? So there's a bit more going on, but the basic principle remains the same. So let's convert kilometers to miles here real quick. So the way I do it is I start with, in this case, kilometers, and then I multiply it by one of the rates that I just gave you. And we look for miles and kilometers, right? Which is the very first one here. But it does matter. We want kilometers to be in the denominator, correct? We want kilometers here. So we're going to put the 1.6093 down here and the 1 mile up there. And then, as you can tell, kilometers, those units are going to cancel out, which is exactly what we want, and we're left with miles. Okay. So in this case, guys, this is very important because you're so close sometimes, but you get it wrong. You multiply numerators, right? You get an answer, and then you divide it by whatever the denominators multiply to. In this case, if I go 12.7 times 1 and then divide it by this, I get 7.89 miles. Okay, and final answers and applied get rounded to 2 decimals. Along the way, we don't round if we can help it at all. We have these crazy calculators here. You can copy paste. I'll show you all those features later on. Remind you of them, I guess. And so there's no need to round along the way. Okay, milliliters to gallons. Same here. And some of you are going to take bio or chemistry. You do this a lot there too. I have gallons and milliliters right here. I just gave you that one, right? So we're going to put the milliliters in the bottom here. Please tell me if I make a mistake before I finish the question, all right? I'd appreciate that. Milliliters there, they cancel out. If you multiply this by 1, and then that answer gets divided by the only number that is in the denominator, 3790, you get 1.45 gallons. I'm going to split this up here so that we don't mix them up. And here's our rate, okay? So this is an example of rates. I've got different units there. So I start with 190 liters for every minute. And my goal is to go gallons and hours, right? So basically I'm going to go from liters to gallons and from minutes to hours. So let's do the liters. Let's get rid of the liters first. Okay, so I basically focus on that first. So I have gallons and liters right here. So I'm going to go 1 gallon has 3.79 liters. And that cancels out right there. So I'm going to highlight liters and liters. Cancel those. So I'm left with gallons. That's perfect. And then I go back and I basically now focus on the minutes, right? I want to get minutes to hours. So you're going to make sure minutes is in the numerator. And then you're going to think of what? You're going to think of 1 hour having 60 minutes. And then you can cancel out the minutes, right? So it's perfect. Right there. All right. Do we know how many seconds in an hour? 3,600. So if you need that as a reminder, you can add that to the box up here. So again, because there's lots going on here, and I know it's probably right now not necessary, but I'm going to go 190 times 1 times 60, right? And so I get 11,400. What is at the top? What unit is left at the top? Gallons, right? That's there. And then in the denominator, you go 1 times 3.79 times 1, which is very irrelevant. It is 3.79. And we are left with hours, right? Perfect. That's not quite your final answer yet. So we want to divide these numbers now. So watch up here, the way I do it. Let me just make it a little brighter for you guys there. There. So what I do is I copy paste. I literally go to 11,400. I hit enter and I divide by my previous answer. I highlight that, hit enter, and then enter one more time. So that's my final answer, 3,007.92 gallons per hour. So now you have it at a unit rate, right? Okay, so that's converting a little bit, the refresher. But you will also be asked to convert two-dimensional, so areas and volumes, okay? You may use the rates given above, but remember that the units must be squared or cubed, okay? That is very important. So what do I mean by that? 1 squared meter has how many squared centimeters? I want you to go back to this fact right here. 1 meter has how many centimeters? 100, right? We know that part. This is one-dimensional. If you were to square this whole expression, okay, you end up, right? 1 squared is just 1. Meter squared is meter squared. 100 times 100 ends up 10,000 centimeters squared. This is the reasoning I want you to have as you deal with squared units, okay? That we had to square the regular conversion rate to get the right answer. So the answer is 10,000 centimeters squared. By the way, if you look up here, do you remember how to square? I should have given you this today, I know. There's the X2 button if you look up here. x2 squares, you get your 10,000. Oops. Something with the lighting here. I need to work with that. There. Or you can go 100 and then use this hat button right here. Look at where my pencil is hovering. Right? Hat 2, that squares it as well. Just a reminder. Okay. What about 1 foot and squared inches? Don't say 12. Okay, that would be wrong because it's squared units. So you got to go 1 foot has 12 inches, and we're going to square that, right? And now you know that a square foot, what's 12 times 12? 144. Yeah, it's been a while, right? So 144 squared inches. So please don't say 1 square foot is 12 inches. It's not true. If it's just a foot, yes, but it's not, right? Next, yard and feet. Oh, a yard has 3 feet, right? No, because it's a cubic yard. So 1 yard has 3 feet, that's correct. This one is very important. The province likes this one in particular. So 1 cubic yard, what's 3 cubed? 27, right? 3 times 3 is 9, times 3 is 27. I would say at the end of this, when we're done this, at the very least, I would have these ones on my study sheet. And the last one here, we know that 1 meter, where's meter and cubic yards? Oh, it's right up there. One meter has this many, sorry, I mixed it up, didn't I? What did I get wrong there? Oh yeah, this is supposed to be yards, my bad. 1 yard has 0.9144. And if you cube it, right, you take your calculator, you put 0.9144. Cubing, there's no option but to use the hat button here. Hat to the power of 3. So 1 cubic yard is 0.764. We're going to round at that point, 46 cubic meters. I made a mistake. Did you catch it? This is asking 1 cubic yard, how many cubic meters, but we want to know how many cubic yards are in a cubic meter. Hold on. Sorry, you're going to have to use your eraser for the first time today. Oh no, second time already. My bad. It's because I didn't give you this one. I'm just going to tell you this one. 1 meter has 1.0936 yards. I didn't give you that one. If you cube it, you find that 1 cubic meter has 1.3079 cubic yards. I'm not going to highlight that one, so I'm just going to tell you these 3 here I would definitely have on my study sheet. Okay. All right. So how do we apply this to word problems? So some students prefer to convert all the dimensions given individually, then proceed to find the final area or volume. Just make sure you don't round along the way. So for example, a circle has a radius of 9 inches. Calculate the area in square feet. Okay. So method 1, we convert the radius. We go 9 inches. We're going to say that 1 foot has 12 inches. We cancel that out. And watch what I'm going to do here. 9 times 1 is just 9 over 12 feet. And here's something I want you to remember. Whenever you're given inches, anything in inches, just put a 12 under it and you turn it into feet, just like that. Okay, guys? Something is 5 inches and you need it in feet, just put a 12 under it and you've converted it effectively to feet. Right? Anything in inches, put a 12 under it. I just shown you here the long way, but we could have gone straight to that. We could have just gone 9 over 12, you have it in feet. Okay. Why am I not turning it into a decimal? Because we have a calculator that can handle it, right? So what's the area of a circle? Pi times radius squared, correct? So that's pi 9 over 12 squared. Let's figure out what that is. On this calculator, pi is found by going second, and then the hat button to call pi. Tomorrow you'll have a chance to practice that. And then I use brackets, times 9 over 12, close the bracket, and I will just square it. And there you go. It's 1.77 if you round it to 2 decimals. It's very pixelated, eh? It's like Minecraft. Oh, it's feet. You still play Minecraft? Yeah, that music just drives me nuts sometimes. So my kids are playing it in the basement. Dun, 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 dun. Okay. Method 2. I should have it playing as I'm teaching. Maybe for some of you, you're like, ooh, math, I love it. Okay, method 2. Sorry, sometimes I joke and it gets us off track. Method 2 is this. You don't convert right away. You're like, okay, pi r squared. So I'm just going to go pi. I'm going to put the 9 in there and square it. And you get 81 times pi, right? You get this. 254.469. Don't round yet because you don't have it in the units that we want them in. This would be squared inches. Okay? Now we convert. So we would take that number. What I'm trying to say is it doesn't matter. That's what I'm trying to say here. Either way, you would have gotten the right answer. What am I going to use to convert this now? Squared inches. We just did that up here. See this one? This is the one, the conversion rate you would want to use. This one up here. So you know that 1 square foot has 12, sorry, I almost made that lethal mistake. 144 squared inches. And you cancel. And then, so all you have to do now is 254.46 something times 1 divided by 144. So it's really just divided by 144. So you get 1.77 square feet. So it's the same answer. I just want you to be aware of your units. That's what I really want you to be aware of. I know that you know how to find the area of a circle. That's not the main point here. It's the units, okay? All right. what's our time here? Okay. I will ask you to, for the rest of today's class, work on page 2. And there's an and to this. I'm gonna post. Oh, you can't see that. But anyways, page 2. I'm gonna post a video. I think it's just one video that I'm gonna ask you to watch and fill in pages 3. So watch and fill pages 3 all the way to all the way to 9. I know. And this is why. I'm going to tell you 2 reasons why. Technically, this course assumes that you know all your formulas, that you just know how to find the surface area of a hemisphere, which is half a sphere, how to deal with a pyramid, a cylinder. They expect you to know that, but I know that you haven't done it in a while, okay? So I need you to review that, okay? I need you to have all these formulas filled in at the very least. I explain how the formulas are built, how they're put together, and it is a very important start to our next section, okay? To understand how a box works, a rectangular prism, to understand how pyramids work, what is a slant, what is a height, all those things. I need you to know how to do that. The one thing that here, listen carefully because it's going to save you time. The one thing I don't need you to worry about is page 6, a rectangular pyramid where the base is a rectangle. I would say go to page 6 and just tell yourself, omit, fast forward this part, like skip this part until you get to your cylinders, right? And then when you get to the cylinder, there are more formulas there, okay? I will say that, so don't do page 6, okay? Every time I give you formulas, I do an example where I fill in how do I use the formula to explain, right? How would you use it in different cases? Sometimes we don't need the circle at the top and the bottom of the cylinder, okay? How would you adjust your formula to make that happen? So I would like you, I know that's a lot, but that way in class, we can like focus more on diving right into using these formulas for problems, okay, solving problems. Does that make sense? Yeah. And I know the video is probably not the greatest quality. I don't edit them. So if there's a lot of like ums and ums or whatever, you're just gonna have to forgive me and just speed it up if you need to, okay?